In sections 7.1 through 7.3, we're going to be doing hypothesis testing. Let's suppose we have an automobile manufacturer that advertises that its new hybrid car has a mean mileage of 50 miles per gallon. They're claiming that on average this car is going to get 50 miles per gallon. So let's just say that mu is equal to 50. That's what they claim. Now we could take them at their word, but what if we suspect that the mean mileage is not 50 miles per gallon? How would we be able to disprove that the advertisement is actually false? To do this, we're going to talk about hypothesis testing. It is a statistical method that uses sample data and a test statistic to evaluate a hypothesis about a population parameter. It allows us to determine whether or not data obtained from a random sample supports or fails to support a particular hypothesis. When testing our claims, we state two hypotheses, one which represents the claim and the other which would represent its complement. The first step to any hypothesis test will be setting up these two hypotheses. The first one is called the null hypothesis, which is denoted as H sub 0. It is a statistical hypothesis that contains a statement of equality. So the null hypothesis will always contain some component of equality. The possibilities are that the mean is greater than or equal to a value, the mean is less than or equal to a value, or perhaps that the mean is exactly equal to a value. So these are the three different forms that a null hypothesis can take on. Corresponding to each case for the null hypothesis, we have what's referred to as the alternative hypothesis. This is also sometimes called the research hypothesis. This is the complement of the null hypothesis and contains a statement of inequality. The three different possibilities would be mean is less than a number, mean is greater than a number, or that the mean would not be equal to some number. These kind of pair up, if you will. The opposite of greater than or equal to would be less than. So in a study, if your null hypothesis was that the mean was greater than or equal to a value, the alternative hypothesis for that same study would be that the mean is less than a value. If the hypothesis for the null was the mean is less than or equal to a number, the opposite or the complement of less than or equal to is strictly greater than, and then the complement of equals to would be not equals to. Let's take a look at example 1. In example 1, they use the given statement to represent a claim and then write its complement and state which one is the null and which one is the alternative. For the first part, they say that the mean is less than 128. Because this is strictly less than, that's going to make it the alternative hypothesis. So in this case, HA, which is the alternative, that's going to be the claim. The mean is less than. The opposite of less than would be greater than or equal to, and so that would be our null hypothesis. Okay. This is always the first step in any hypothesis test, is to determine what is the null and what is the alternative hypothesis. Remember, the way you can kind of keep it straight is that only a null hypothesis can contain some component of equality. The alternative hypothesis is always a strict type of inequality or not equal to. Let's take a look at the second part. This would say sigma squared. If you remember, that's the population variance. This would say that the variance is greater than or equal to 1.2. Because it contains that equal to part, that means that this is going to be the null hypothesis, and it was what was claimed in the beginning. So the null is that the variance is greater than or equal to 1.2, which is our claim. The opposite of greater than or equal to would be strictly less than. So for this one, the alternative hypothesis is the variance is less than 1.2. In part 3, they're saying that a population proportion P is equal to 0.21. So that would be our null hypothesis because it's equal to, and that was what was the claim. The opposite of the complement of equals would be not equals. So the alternative hypothesis is that the proportion is not equal to 0.21. let's get some more practice setting up the null and alternative hypothesis. Suppose that we are told that as stated by a company's shipping department, the number of shipping errors per million shipments has a standard deviation that is less than 3. So they're making the claim that the standard deviation sigma is less than 3. Because it's of the form less than, that's going to make that the alternative hypothesis, which is the claim in this case. The complement of less than would be greater than or equal to, so the null would be that the standard deviation is greater than or equal to 3. In the next one, they say that a state park claims that the mean height of the oak trees in the park is at least 85. So they're claiming that the mean is at least means greater than or equal to 85. Because the operation is, or the symbol is greater than or equal to, that means that that is going to be the null hypothesis, which is what was stated, so that's the claim. The complement of greater than or equal to is less than, and that would be our alternative hypothesis. In the next part, they say according to a survey, 74%, that's a proportion, that's P equals 0.74, of college students own an MP3 player. Because they're claiming that it's exactly a value, that's going to be the null hypothesis, P equals 0.74, which is the claim. Its complement would be the alternative hypothesis, which is P is not equal to 0.74. Ultimately, when we decide to judge on one of our hypothesis testing, our conclusions will always be one of two types. We will either make the decision to reject the null hypothesis, or we will make the decision to fail to reject the null hypothesis. Okay. One of the things to keep in mind is that this is going to be chalked up to probability after all, and there is a probability that we do make the incorrect decision. No matter which hypothesis represents your claim, we always begin by assuming that the equality condition in the null hypothesis is true. So by kind of the benefit of the doubt, we assume the null hypothesis is true unless we have evidence to suggest otherwise. So for us, whenever we go to make a decision, the decision will either be of the form reject the null hypothesis or fail to reject the null hypothesis. When we write out our conclusion, if we reject the null hypothesis, we will always say that there is enough evidence, and then it'll either be to support the claim, if the claim was the null hypothesis. On the other hand, if the alternative hypothesis was the claim, then we would say that there is enough evidence to reject the claim. If you fail to reject the null hypothesis, if we fail to reject, then we will conclude that there isn't enough evidence to either support or to reject the claim. So at the end of the day, the whole support or reject depends upon which hypothesis the claim is. If the claim is the null hypothesis, then we will always use the words reject. If the alternative hypothesis is the claim, then we will always be picking the words support in these cases. We now get to the question of how do we actually perform the hypothesis tests. We start by assuming that the population mean is equal to the value that's stated in the problems, and then we see if our sample data would be reasonable. And to determine reasonable, we will find a probability value, which brings us to the p-value. So in general, there are two different that are compatible methods of approaching a hypothesis test. There's the method of the test statistic, which we will see a little bit. It'll show up in the calculator when we do some of these computations in a little bit. It is also something that's going to be asked as a subpart of some of your homework questions on the MyStatLab. We will not give it much emphasis. We are going to take the second approach, which is what's referred to as a p-value approach. The way the p-value approach works as follows. we're going to investigate the probability that the test statistic K could occur if P is smaller than some predetermined level of significance. We will reject the null hypothesis. In this case, the level of significance is going to be denoted by alpha. Commonly used levels of significance are alpha equals 0.10, alpha equals 0.05, and alpha equals 0.01. In the notes, this is going to be very, very important. Throughout this entire rest of this chapter, you need to know this condition for our decision. Again, at the end of the day, the decision we always make in a hypothesis test is either to do one of two things. We will either reject the null hypothesis, or we will fail to reject the null hypothesis. That decision is all based upon comparing this p-value, which we'll calculate in a little bit, and comparing it to the level of significance that is stated at the beginning of the problem. To give you some insight and some kind of background into how this would kind of work overall. For example, if we flip a coin, okay, and let's suppose we assume that the coin is fair. If we flip a coin 10 times, we would expect to get, on average, 5 heads. Okay. Now, let's suppose that I actually conduct that experiment, and I flip a coin, let's say, 10 times, and out of my 10 flips, we're probably not going to get exactly 5 heads every single time, but on a particular flip, I might get, let's say, 8 heads out of 10. Can that happen? Absolutely. Would it be unusual? Not necessarily. I mean, getting 8 out of 10, while it's, it's an incredible amount of heads, that wouldn't be enough evidence to maybe suggest that the coin was doctored in any way that perhaps favored the heads outcome. Okay. So with that one trial, it's not enough evidence to kind of rule out and say that the coin is, an unfair coin or would prefer heads. Let's suppose, though, that we take that same coin and we flip it 1,000 times now. And let's suppose that out of those 1,000 tosses, we get now 800 heads. It's the same proportion of heads as what we got when we flipped it 10 times, but now having a larger sample size, it would make the probability of getting that observation, that 800 heads, would be much, much less likely than getting 8 heads out of 10. So with that much evidence, some people might be skeptical enough to say, wait a minute, I think something's going on here. This coin seems to be favoring the heads outcome. Could it happen it's just purely coincidental and random? Absolutely. But it's one of those things that kind of makes you pause and say, wait a minute, maybe there's something here, right? So that's kind of, philosophically the underpinnings of what we're going to be doing when we're comparing some of our sample data to this level of significance. Let's take a look at example 3. We want to determine whether to reject or fail to reject the null hypothesis at the level of significance. Let's suppose that we have an alpha value of 0.01 and a p-value of 0.0142. My suggestion whenever you're working through these problems or whenever you're doing ones later in the section is be consistent. Make sure you know this condition for the decision, whether it's reject or fail to reject, and always try to get into the habit of keeping p and alpha on the same side. That when you write it up, it matches up directly with what our test condition is. P is 0.0142. Alpha for part A is 0.01. If we compare the two, 0.0142 is greater than 0.010. Because P is greater than alpha, the decision would be to fail to reject the null hypothesis. So fail to reject HO. If P was, let's say, 0.06, then 0.0142 would now be less than 0.06. And when P is less than or even equal to alpha, we will make the decision to reject the null hypothesis.